All right, 5.3. I talked a little bit about the translation, reflection. Actually, I'll do that real quick, just because I only talked about a translation and reflection. Yesterday, if you didn't get it, you'll get it today. When we translate something, it gets moved across a graph, right? Now, when we do that movement, and I'll use this figure here, it looks like it moves this way. Theoretically, figures can move right or left, they can move up or down. It looks like they move sideways. With this one, what they had us do is they had us take all of these points, C, E, and D, and they had us translate them. And we all translate, anytime you translate something, all the points get translated the same direction. So this said down 4 and left 6. So down 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. There is what we call C prime. I use the prime notation to differentiate between C and C prime. Differentiates between 2 points. I do the same thing with E. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. There is E prime, and D prime gets done the same thing. Down 4 over 6. 2, 4, 6. Right here, here is D prime, and I draw my figure. And when I draw my figure, it should look exactly the same. Again, all I did was I moved it down and over, and it looks like it slid. 2 ways to tell if you didn't do it correctly is this. 1, my figure doesn't look the same. The other, and I'll keep this point right here, go back to here, is what in the end, what they wanted us to do is they wanted us to draw lines to connect these points that we translated. If I draw a point from E to E prime here, notice that this purple line is not parallel with the black lines. When you translate something, the lines stay parallel. That's how you know you translated it properly. Is if the point between C and C prime and E prime and so on, all those lines will be parallel. Here, the purple line will eventually crisscross with the black line at some point. Maybe not in here physically, but remember, lines continue in each direction, right? So there is the translation. The reflection basically says, hey, we want to reflect this figure. All right, well, what happens when we reflect? Well, we have to reflect across a line of reflection. How do we do that? Well, in this case, it tells me the line of reflection is x equals 0. What does that mean? Well, go back to y equals ax minus h squared plus k, where my vertex is h comma k. My axis of symmetry is x equals h, because in this particular case, the x minus h is relative to the x-axis. When I'm doing, well, how is that? Sorry, somebody's at the door. So why are they the same? They're the same. So this is x equals h. Well, if h is negative 3, that means my axis of symmetry is negative 3. Go back to why that is. Well, it's a vertical line, x equals negative 3, and here you draw my parabola, and there you go. Well, the point of all that is x equals 3 is a vertical line. So over here, x equals 0 is a vertical line on the y-axis. Okay, so what does that have to do with the reflection? Well, I use this example to try to explain this, or actually today. If you look and see this picture right here, you can see you have the castle. Well, in front of the castle is water. If we go back to those times, yes, there's a moat there, but you also see the castle there. Where the castle and the water meet is what we call a line of reflection. This window right here, if we were to measure from the water to the window, it would be the same distance as from the water to the window live as it would be from the water to the window in the water, if that makes sense. In other words, this window here, if it's 10 feet to the left, when I go to reflect it, it better be 10 feet to the right. So if x equals 0 is my line of reflection, just reflect the points. C is 4 units to the right, go 4 units to the left. There is C double prime. E, 3 units to the right. 1, 2, 3, 3 units to the left. There is E double prime. And then D. Some of you might be saying, well, gee, D is D. It's 0 units to the right, which means it goes 0 units to the left. So it stays there, and there's your figure. Now, it doesn't make sense. It's not orientated the same way. Sure it does. When we reflect, we flip. See how I see the front now, and then I see the back? That happens. All right? So that's what's going on there. That's the first part. So that's done with 5.2. Now we move on to 5.3. All right? So I can get rid of all this. I can go back and get rid of this. And when we look at 5.3, 5.3 talks about, hey, I need a congruence statements. The topic is congruent statements and corresponding parts. All right? I'll be out there a bit. The congruent statements. What is a congruent statement? A congruent statement is just a fancy name for equal. What does equal mean? Equal means congruent. Congruent means equal. That's what that means in terms of geometry. All right? How about corresponding parts? Well, corresponding parts are just the same part or parts. They're the same. Now, I have to go through this for you to really kind of truly fully understand what's going on. The example that they give is they say angle A is congruent to angle F, segment AB congruent to segment FG, and so on, and they give us a couple other ones. If you look in here, you will see 6 different letters. There's some A's and B's and so on. There should be 6 different letters, which would indicate that I'm talking about 2 figures. There's 2 triangles. How do I make sense of this statement? How do I make congruence statements and state that one figure is congruent to another? Well, if there's 6 letters, there should be 2 triangles, 3 letters for each triangle. You just begin. Angle A is congruent to angle F. Well, where does angle A go in triangle number 1? Angle A can go any one of the 3 places you want. I just keep it simple, and I kind of always start with the lower left. Angle A is congruent to angle F. A is lower left in figure 1. F is lower left in figure 2. These angles are congruent, so I'm going to indicate them. And this is how I indicate angles are congruent in geometry. I use a little arc. Okay? I apologize for the bad triangles. Next statement. AB. I've used this one. AB. Segment AB is congruent to FG. Well, A is here. What about B? You can put B at the lower left or lower right, or you can put B at the top. Doesn't matter. Let me put B at the top. Okay, so if AB makes up the left side of the triangle, then FG has to make up the left side of triangle number 2. These 2 sides are congruent because it states that. Angle B is congruent to angle G. Well, I'm going to put 2 arcs here. 2 on angle B, 2 on angle G. Why? Because I don't know that A and B are congruent, and if I only put one up where B is, I might get confused. Use that one. The last statement is BC is congruent to GH. Well, where is C? A and B, those 2 angles are already taken. C has to go here. That means H has to go here. And it says BC is congruent to GH. I have to put 2 hashes here because, again, I don't know that BC and AC are the same length. It does not tell me. I make a congruent statement. All I'm doing is saying one triangle, and I'll just go ABC, is congruent to, I have to say the same for triangle number 2. Triangle F, not P, F, G, H. Notice I went left top to right. I have to go left top to right. So when I look at this, I know A and F are the same. They're corresponding. B and G are, and C and H are corresponding. Now, why are these corresponding? I can say that this is corresponding by angle, side, angle, side, angle. Because these parts, A and F, that correspond or are the same parts, AB and FG, and angle B and angle G are the same. So, angle, side, angle. Now, what does that stand for? Yes, over here. So maybe at the top of your paper, you want to put ASA, which is angle, side, angle. SAS, side, angle, side. and SSS is side, side, side. So those are our congruence patterns. Okay, here's a congruent statement. Here's a congruent pattern. This one, based on the information that they've given me, again, I use this, is also congruent by side, angle, side. Notice these sides correspond, these angles correspond, and these sides correspond. So I could say, in this case, or SAS. I could say that. One more I want to show you, which is what I did in class, just to be fair. Look at the very first one here. All right? The very first one gives me this information. Well, again, there should be 6 letters here. 6 letters indicate 2 triangles. Start somewhere. And hopefully this will make more sense when we do this one. ML. I get a start. Where do I start? Now, you don't have to number your triangles. I'm just doing that for the sake of learning this. I can start at the top. I can start at the right. I can start at the left. Again, I just default to the lower left. I just always start there. ML. Where do I want to put L? L can be at the right or L can be at the top. It doesn't matter. ML. If I went ML, which is the left side, guess what I better refer to the left side over here? ZJ. So Z and J better be left sides. And hey, we know that those are the same, so I'm going to indicate that they are right away. I've used this one. Next one, LR. Where does R have to go? Well, M's already taken over here, so R has to go on the right side. So LR, going to mark that with 2 because 1's already taken. JB. B better go on the lower right, and that better get 2 hash marks. So I've used these 2 statements. Angle L, that's horrible. Redo this. Angle L is congruent to angle J. So all I need to do is indicate as such. Angle L is congruent to angle J. Congruence statement, again, I get to start wherever I want. M, R, L, so I went lower left to right to top. Is congruent, I've got to do lower left to right to top over here. Triangle Z, B, not L, and J. I've got to go lower left, right to top. So there's my congruent statement. Now, what is my reason? Well, my reason should be side, angle, side, or SAS, because over here I have side, angle, side as well. All right, and there's your info for that, and your assignment has been posted. 5.3 has been posted. So ask questions if you need to. Again, it's just a thinking game. They just want to get you to think about what you're doing. All right, no calculation involved. I'll see if anybody's got any questions tomorrow in the morning about this. All right, enjoy.